Today we're going to talk about how to multiply polynomials. We're going to start by just multiplying monomials. Remember, monomial is one term. Another thing we need to remember is our exponent rules. The product rule is multiply the coefficients and add the exponents of like bases. So, for example, we have a coefficient of 8, 4, and 2. So we multiply those. 8 times 4 is 32 times 2 is 64. And with the exponents, we add, their like base would be x. 3 plus 1 plus 2 would be 6. So 64x to the 6th. This one, multiply the coefficients. 3 times 5 is 15. A, we have an exponent of 1 and 2, so exponent of 3. B, we have exponent of 4 and 1 is 5. So if we can remember to multiply the coefficients and add the exponents, that will be beneficial as we multiply any type of polynomial. So now if we have a monomial times a polynomial, we have to use the distributive property. I have to multiply this 3a cubed times both pieces in parentheses. So that's the distributive property. 3 times 2 is 6. A to the third times a to the fourth would be a to the seventh. Remember, we add those exponents. And then we take a to the third times negative 4a squared, so I get negative 12a to the fifth. And I look at these, they are not like terms, I can't combine anything, and we're done. So we've learned the distributive property before, we've learned the product rule before, it's just kind of putting those two things together. So let's look at one more that's a little more difficult. Let's do this one. Negative a squared b times 9ab. So this one, the coefficient is just negative 1 times 9 is negative 9. A squared and a gives me a to the third. B and b gives me b squared. Negative a squared b times 7a is negative 7a to the third. B. I don't have any exponent with b to add, so it just stays as b. And then the last piece, we have negative times a negative gives us a positive 3. I don't have anything to add with a, so it's going to stay a squared. B to the first and b to the first makes b squared. Again, I look at these and they are not any like terms, so I can't add them together. Like terms have to have the same variables and the same exponents. Next, we're going to look at multiplying binomials. Remember, binomial has two terms. There's two different methods we use for multiplying binomials. We have the FOIL method and the box method. The FOIL method is FOIL because it stands for first, outer, inner, and last. You can kind of see from this example, first term times the first term. Outer would be the two on the outside. Inner, the two on the inside. And last would be the last term from each of the parentheses. So we have to multiply all four of those parts. It's basically like distributing, but distributing the 2x and distributing the 7, so it's kind of double distributing, and then we have to combine like terms. So following this example, we're going to look at x plus 4 times x plus 2. So first, we would do x times x. X times x gives us x squared. Outer would be x times 2, so that will be 2x. Inner, 4 times x is 4x. And last, 4 times 2 is 8. So I have my four pieces that we multiplied, and then I look for like terms, 2x and 4x. So my final answer would be x squared, 2 plus 4, 6x. And I leave the x squared and the 8 because those are not like terms. That's my final answer. Do another one, that's the FOIL method. First, 2x times x would be 2x squared. Distribute again on the outside, 2x times negative 6 be negative 12x. And then we distribute the 5, the inner 5x, and last 5 times negative 6. My arrows are a little messy. Combine like terms, keep that 2x squared out front. Negative 12 plus 5 would be negative 7x, and keep our negative 30. Next, we're going to look at the box method. So we're going to get the same exact questions if you look here. Same exact questions we did, but we're using a different method. And after we do these, you can decide which method you like best and continue with that method. You don't need to know both of them. So the way the box works is we create a box that is the right size. So since we are multiplying binomial times binomial, I'd have a 2 by 2. If we had a trinomial, I would have 3 on one side or 3 on the other side. Okay. Then we write one expression along the side and one along the top. Make sure we keep the signs with the terms. So x plus 4, it doesn't matter if you put it on the side or on the top. I'm going to go ahead and put the x plus 4 on the side and then x plus 2 on the top. Okay, each term, each monomial gets one part of the box. Multiply each set of terms and combine like terms. So this will look like a Punnett square that you may have done in biology. We have x times x to get x squared, x times 2 to get 2x, 4 times x, 4x, 4 times 2 is 8. And if you notice, look at these terms are exactly the same as these terms we had over here because it's the same problem. It's just a different way to organize your work. And I can see that these two are like terms. I'm going to put x squared first because it has the biggest exponent. Add these together to get 6x and then our constant plus 8. I get the exact same answer. It just depends on how you like to organize your work. Okay, one more example. 2x plus 5, I'm going to go ahead and put along the side. And x minus 6, I'm going to put on the top. Again, it doesn't matter which one you put on the side versus on the top. That's your choice. 2x times x is 2x squared. 2x times negative 6 would be negative 12x. 5 times x is 5x. And 5 times negative 6 is negative 30. Again, I have my like terms. Combine those to get negative 7x. And I leave my negative 30 at the end. Again, same answer, just a different way to organize your work. You get to decide how you want to do the rest of the problems. All right, last we're going to look at multiplying binomials and trinomials. It's going to be the same process as the FOIL in the box that we just did over here. It's just one extra step because we have a trinomial, so we have to multiply just a little bit more. So with a binomial, we can still use FOIL process and think first, outer, inner, last, but there's a little bit more because there's 3. So I have to distribute the 2x to all 3 pieces, and I have to distribute the negative 7 to all 3 pieces. It's just kind of big distributing problem. So 2x times 3x squared is 6x to the third. Remember, you add those exponents. 2x times x would be 2x squared. 2x times negative 5 is negative 10x. That's the distributing just the beginning part. Then we have to distribute negative 7. So I have negative 21x squared, negative 7x, and plus 35. So then we just need to combine like terms. So 6x cubed, there's nothing that combines with that. But I do have 2x squared and negative 21x squared to get negative 19x squared. Then we have negative 10x and negative 7x, negative 17x, and I have that plus 35 at the end. Same process of distributing, it's just distributing a little bit extra. Okay, this box, we have a binomial times a trinomial. It's the same problem. We made a 2 by 3 box to put the 2x minus 7 this way, and the 3x squared plus x minus 5 this way. You could make a 3 by 2 box and do it the other direction. It doesn't matter. Then we multiply 2x, 3x squared, 6x to the third, 2x and x, 2x squared, 2x and negative 5, negative 10x. Now we multiply negative 7, we get negative 21x squared, negative 7x, and a positive 35. Look at like terms. We have those two, and we have these two. So 6x cubed starts us off with the biggest exponent. Our x squared terms give us negative 19x squared. Our x terms give us negative 17x, and our constant is 35. So we get the exact same answer, again, just two different methods. From now on, you can choose if you prefer the box method or the FOIL method.